Hi, class. So we are going to start section 3, and this section is about orthographic and isometric projections. All right, so orthographic projection is a method of representing a three-dimensional object in two-dimensional space by projecting the object's views onto perpendicular planes. So it is commonly used in technical drawing and engineering design. It allows the viewer to see different views of the object without the perspective distortion. And this ensures that dimensions are accurate and can be measured directly from the drawing. And so where does orthographic come from? Ortho means right angle, so like that. And then graphic means drawing, and so orthographic means a right angle drawing. So an orthographic projection is a view of an object that is perpendicular to a surface. These views are projected onto perpendicular planes and aligned to represent the object's true shape and size. These planes are known as projection planes. So this here is a projection plane. So if I were to look at this three-dimensional object and I projected this view onto the projection plane, I would get this right here. All right, and the glass box method is where an imaginary glass box can be placed around a three-dimensional object. The sides of the glass box represent the 6 principal planes, and each side of the 3D object can be projected onto each of these glass planes so that an observer's line of sight, it is perpendicular to the plane. So if you imagine a glass box around this 3D object, and then you unfold it so that it's flat, you'll see 6 principal views because there are 6 sides of this glass box. All right, and those views are the front view, the top view, the right side view, the left side view, the rear view, and the bottom view. And so in the US, we use third angle projection. Um, and so the standard views for the third angle projection are top, front, and the right side. So it's these 3. So most drawings can be described with just 3 principal views. So the top, front, and right side. But more can be shown for complex objects. All right, and so here I have this object, and then these are the 6 principal views. So I have the front, the top, the right side, the bottom, and the rear. And so notice how the bottom and the top, they mirror each other in a way. And then the left side mirrors the right side, and the rear mirrors the front. And some of these lines are just going to become hidden or they're showing. And so that's why we only need to use the top, front, and right side to fully describe this object right here. All right, and so if we just use 3 principal views, we would get something like this. All right, and there are 3 surface types that we need to be able to recognize, and that is a normal surface, and that is a surface like this. So if it is a normal surface, that means it is perpendicular to the plane, and it's only fully shown in one principal view, and in the other principal views, it'll be an edge view. All right, and then there is an inclined surface, and that is a surface that can be seen in 2 principal views. So something like this. This is an inclined surface. And so we can see this both in the top view, and we can also see it on the left side over here, or the front view. And then an oblique surface is a surface that can be seen in all 3 principal views. So this surface right here is oblique, so we can see it from the top, we can see it from the front, and we can see it from the right. All right, and so This is just describing the method to solve orthographic projection problems. So if you're given an image like this and it's asking you to create three principal views of this shape, then you would create a front view, a top view, and a right side view. And these all need to be aligned with each other. All right, so first you would set up the boundary boxes for the top, front, and right side. And these will show the height, the width, and the depth. So this would be the depth. Oh, wait, this one right here actually, of the object. And you would also line them up perfectly. So if you look at this object, for example, we have 1, 2, 3, 4, 5, 6 for the front. So 1, 2, 3, 4, 5, 6. We also have 6 for the top. So maybe if I go back here, it'll be a little bit more obvious. 1, 2, 3, 4, 5, 6. Because because of how these are aligned, that's why you can see that. And then the depth is 1, 2, 3, 4, 1, 2, 3, 4. And then you can see this right side view, this is showing the depth. 1, 2, 3, 4. The height, 1, 2, 3, 4. 1, 2, 3, 4. And then the height here, 1, 2, 3, 4. So these are all going to be aligned and they're all going to be related as well. All right, and then you want to place all the normal surfaces on each of the principal views. So this is a normal surface, so we'll draw a line there. We see a normal surface right here, and we have another one on this side. And then we want to place the inclined and oblique surfaces. So right here, this is going to be an inclined surface, this one right here. And so we see it both on this view, and we're going to see it on this view here. Sorry, let me look at that one more time. Actually, this one is also a normal surface, but the line wasn't showing right here, because that's only shown in this view. Okay, and then we're going to place the oblique surface. So if I look at this view, right, for example, the right side view, I have this oblique surface, and I see that it goes 1, 2 units up, and then the other corner is up in that corner. So then I create a line right here. And then in the top view, same thing. So it starts in that corner, and then it goes 1, 2 units over. So 2 units over, and then 2 more in this direction. So then I connect my line this way. All right, and then you're going to add any hidden surfaces. There's none for this example, and you would add any other features such as holes, slots, grooves, and add center line marks to the centers of curves or circles or arcs and other features. All right, and so isometric projection, this is a method of visually representing three-dimensional objects in two-dimensional space. So this will allow the reader to see all three sides of the object at once. So it is a 2D drawing that looks 3D. So for example, this drawing, this looks 3D, but it's actually just drawn on a piece of paper, so it's 2D. So this is just a representation of a 3D object. So the isometric views are used to help the reader visualize the object in 3D space. So we're not going to be doing any 3D modeling for now. We're just going to be doing isometric projection. So we're going to create 2D drawings that look 3D. All right, and so you would start at the origin point, and then you would draw the lines at 30-degree angles from there. And you can create a 3D isometric box. You would establish the width, the height, and the depth. And then you'd place the normal surfaces on each face of the box. and then you would remove whatever unwanted lines that you have. All right, and then we're going to go over creating an isometric projection drawing in AutoCAD. And we will also be creating some drawings through hand sketches as well in this section. And so to create an isometric projection drawing in AutoCAD, you would use the IsoDraft command. And you would also turn on polar tracking with it set to 30, 60, 90, 120. So that way you can get those nice angles. All right, and then to make an isometric circle, you have to do that in a very specific way. You would actually use the axis and ellipse, and then you would choose iso circle. And then you would draw it on whatever plane that you have chosen. All right, and so I'll go ahead and create some videos for these assignments. And that wraps up section 3, at least for now. Thank you.